Today we will learn about the metric units of measurement. The metric system is a base 10 system. A base 10 system is a system that is based on tens. Our place values are also a base 10 system, meaning that the tens are 10 times as large as ones, the hundreds are 100 times as large as ones, the tenths are 1/10 as large as the ones, hundredths are 1/100th the size of the ones. Each place value, therefore, is a multiple of 10. The metric system has quite a few prefixes, but before we talk about the prefixes, let's talk about the different bases. There are 3 different bases that we use quite often in the metric system. The first base is that of length. Length in the metric system is measured in meters. The base for meters is a lowercase m. When we'd like to measure volume, we measure it in liters. And liters is a capital L. And when we measure mass, it is measured in grams, and its abbreviation is a lowercase g. Now, the metric system has a little saying that can help you remember the order. The saying is kittens have dander, but dogs catch mange. The first letter of this is the first letters of each of the prefixes. So, the first letter of kittens is K, have is H, dander is A, B is base, dogs is D, catch is C, and mange is M. These letters now represent the letters we use for the prefixes. K is the abbreviation for kilo. H is the abbreviation for hecto. And D actually has an A next to it since there are 2 D's and we need to keep them separate. This D has DA, which can be remembered because of dander, starts with DA. And the DA is for deca. B is for the base, and the base can be any of these 3 bases, meaning it could be a meter, a liter, or a gram. Then we have the second D, which is deci, C, which is centi, and M, which is milli. Each of these is a multiple of 10, with base being similar to the 1 when we were doing place values. So, if the base is similar to 1, that would mean deca is similar to the tens, hecto would be similar to the 100s, and kilo would be similar to the 1000s. And going the other way, deci would be similar to the 1/10ths, centi would be similar to the 1/100ths, and milli would be similar to 1/1000th. As you can see, each time I move between a base and one of its numbers, it is a multiple of 10. In a moment, we will be learning how these things are applied. But before we do that, let's label that kilo is the largest and milli is the smallest. Now, anytime we use milli, we would then have to have something following it. The something following the prefix is whatever the base's name is. Therefore, if we were discussing meters, it would be millimeters. Let's say we were doing liters, then it would be milliliters. And if we were doing grams, it would be milligrams. Let's look at the first example and see how this is applied. In this first example, it asks us to convert 2.87 centimeters into meters. If you've memorized the saying kittens have dander but dogs catch mange, you'd be able to easily write out the first letter of each of these. And the base in this case would be M for meters. It says that we start out with 2.87 centimeters. Let's write that down. Now, all we need to do is determine how many tens away is the meters from the centimeters. So, if I look from centimeters to meters, I went 2 spaces towards the left. If I take the decimal point that is in my number and do the same thing, I will then have converted my number to meters. Therefore, you can see how the conversions in the metric system can be very simple. All you need to know is how many different units have you moved, and move the decimal the same number of units in the same direction. Try practice problem 1 on your own, remembering to press the pause button. Now, I will work out practice problem 1 for you on the screen. Let's start out by writing our prefixes. Now, let's determine where the hectometers are. Remember, H symbolizes hecto. Hecto is where we are trying to get to. And we started at centi. Let's see how many places that is. 1, 2, 3, 4. We will be needing to move our decimal 4 places towards the left. When we write down that our number is 30 centimeters, it looks as if there is no decimal place. Remember, whenever you do not see a decimal place, it comes at the end of the number. Therefore, we can place a decimal point after the 0, because that would be the end of the number. Oftentimes, whole numbers that do not have decimal values do not have the decimal point, so you may need to write it in. Now that we've written it in, we need to move our decimal place 4 places to the left. 1, 2, 3, 4. And just as we did before, we need to place zeros into those open spaces. This means our answer should be 0.0030. As you can see, the decimal place is 4 places from where it started. This answer is now in hectometers. Now that we saw how it applies to meters, let's look at how it applies to volume or liters. Example 2 is 3.45 liters to milliliters. Let's first write out our prefixes. Now that we have our prefixes, let's find out where we're starting. We're starting at the base because remembering that the base is liters when dealing with volume, and we're trying to get to milliliters, which is the M. As you can see, we will be moving 1, 2, 3 places towards the right. So if we start by writing 3.45 liters, and now we move our decimal place 3 places to the right, or 1, 2, 3, we will need to add in a 0 just as we did when we moved it towards the left. This means our final answer would be 3450 milliliters, or 3,450 milliliters. Now try practice problem 2 on your own. Remember to press pause. Now I will show you how to work out practice problem number 2. Remember, we should write out our prefixes to help us out. Now that we have our prefixes listed, let's see where we will be starting. We will be starting at decaliters, and we will be going to centiliters. If we're starting at deca and going to centi, we will be moving 3 places towards the right. Since we started out with 15 decaliters, we will now need to move our decimal place, which remember goes at the end if none are shown, 3 places towards the right. 1, 2, 3. In each of those places, you should be placing a 0. This means that our new number would be 15,000 centiliters. As you can tell from this problem, converting between liters and milliliters, or deciliters and centiliters, or in general any volume amounts in the metric system, is exactly like converting between the length measurements in the metric system. Next, we will be looking at the mass measurements in the metric system, and we will discover it is solved the exact same way. Let's start with example 3. We have 2.8 kilograms to grams. Remember, write your prefixes down to help you answer the problem. Now that we have our prefixes written, we find where we were starting, which is at kilograms, remembering that the base is grams. We're going from kilograms to grams, and so we move 1, 2, 3 places towards the right. Writing down that we started out with 2.8 kilograms, and then moving our decimal 1, 2, 3 places towards the right, and adding in zeros for any openings, we then see that we get 2,800 grams are in 2.8 kilograms. Now try practice problem 3 on your own, remembering to pause the video. Now I will show you how to solve this problem. Remember, start by writing out your prefixes. Then finding where you will be starting, remembering that your base is the gram. Since we'll be starting at milligram, we'll be moving 1, 2, 3 places towards the left. We start by writing down 17.8 milligrams, and then move our decimal place 3 places towards the left. 1, 2, 3. Remembering to fill in zeros for any open places. This means we have 0,178 grams.